All right, guys, welcome back to another episode of Within Tolerance. This is episode 37, and we're joined with Tony from Air Turbine Spindles, and we're just going to get into it. So, Tony, tell us a little bit about how'd you get into manufacturing, machining? What are you doing now for work? How did you get to that position? And just tell us a little bit of everything you can about yourself. Any cool stories along the way? Just go for it.
Wow, that's going to be a lot of me talking and no breaths. You're going to have to interrupt me from time to time. So first, Peyton and Dylan, thanks for having me on, guys. I appreciate it. It's always fun to share a story, right? And sometimes those stories can be inspirational, and sometimes they can be absolutely boring. So I'll try and be somewhere in the middle.
Perfect.
So I started in this industry 100% by accident. I was actually trying to be a professional soccer player, and that didn't work out. I think it was because I wasn't good enough. But I blame it on other things like size or speed or something like that. But probably I just wasn't good enough. So I went into a machine shop at a fairly young age, and it was kind of mostly for insurance. It was great company benefits and that kind of thing. And so they gave me a go. I was 19, 20 years old. And the first thing I ever ran was just a boring press. And you guys are probably familiar, but you press two buttons to make sure that by pushing just one, you don't smash your hand, first of all. But you push two buttons and a piece of metal comes down and punches a hole in another piece of metal. And it was redundant and boring and repetitive, but the industry, I thought, had a lot of potential, and I thought it was pretty cool. That was in a precious metals company, so a lot of jewelry. And that company was based in Richmond, Virginia. And it was pretty neat in the sense that we would receive all of the precious metals from anywhere around the world, so gold, platinum, palladium, silver, anything fun like that. And we'd melt it down. We had our own refining plant. And one really cool story about working at this facility was that there was a whole bunch of gold brick found in a sunken ship outside the coast of North Carolina. And they wanted us to melt down a portion of it. It was $10 million in brick or something like that. It was a bunch. And it was heavy. You think that gold brick is heavy? Yeah, try pushing it around, picking it up. So we melted it down, and we melted it down into flat pieces of metal because they wanted to make commemorative coins out of this gold to celebrate the ship that sunk in the ocean off the coast of Carolina. And I'm not sure if you guys are familiar being over on the West Coast, but Carolina has a ton of sunken ships, and that area in South was famous for its piracy and all that fun stuff. So there's a lot more down there if they get creative enough to get to it. But that was a really cool thing. So Discovery Channel came through, and they filmed the people, they filmed the plant, they filmed the procedures, and during that time, we were having all of our dies were made by hand, and we had just gotten a machine in the tool and die department, but it was the first machine, so most of it was still the old school way of working things, and so I was pretty fond of that memory. But also, I didn't just press a machine for 7 years of being there. I ended up moving up within that industry, and you guys, Dylan, how old are you?
28.
28. So older than Peyton, and Peyton I know and I've met in person. But neither one of you have probably ever, and if you have, I'm going to be incredibly impressed, but have probably never programmed a CNC machine with a floppy drive in it.
Oh, yeah, I
I have not.
Oh, good for you, Dylan.
Actually, the first shop I worked in, they still had tape readers on the side, but we had converted them. So
all the way into floppy.
Oh, yeah.
That's awesome. Yeah, so that was how I learned. Same like you, Dylan. So 1.44 megabytes, I believe those things were. So not a whole lot of memory in there. And so we did a ton of editing just line by line. So it's up on the screen and you edit from there, and there's no real checks and balances to this thing. So let's just say from time to time we crashed without any kind of checking method. And during this time, it was also a lot of Excel spreadsheet style programming versus the CAD CAM styles that we have today. So we had a guy who was really good at Excel, and he set up a spreadsheet, and then you punch in the numbers that you need for drill holes and et cetera, width and thickness and that kind of thing, and it would create a program out of the Excel spreadsheet. So from there, I was able to learn what I think is probably one of the coolest things I've ever had the opportunity to learn, and it was a software called I Think Software. Have you guys heard of that?
I haven't, no.
I've not.
Have you heard of Six Sigma?
Yeah.
Yeah.
Six Sigma, lean manufacturing, that kind of thing?
Oh, yeah.
So imagine that board that you see on the wall for Six Sigma, and you see the flow chart of how everything goes from one section to the next section, and you're predicting where bottlenecks are. You're looking at the numbers to predict where bottlenecks are. You're seeing where the benefits are created, where maybe financially you're struggling, or where you want to produce more inventory, that kind of thing. So it's that, but automated. So all of those calculations that are in theory based on Six Sigma, you plug in the mathematical calculations to the software, and it activates it in such a way that you can watch to see if it's factual or just made up in our heads.
Oh, wow.
Really, really cool software. And to be honest, man, I struggled at math in high school, but somehow they put me on this project, and I all of a sudden needed to know all sorts of trig. And so that was fun to learn.
I bet.
So beautiful company, but I felt that I needed to learn some more. And we had, I don't know, about 40 or 50 machines there. I ended up, managing a lot of people, doing a lot of programming, doing a lot of maintenance, but I felt it was time to move on. And I went into like radiator coils. So in that industry, there was 304 steels, 316 steels, aluminums from time to time, Inconels from time to time, and it was the first time I ever ran a Haas machine, which who doesn't love a Haas machine, right? So
Exactly.
so we had a VF6, and they bring me in, and they go, so we don't know how to run it, and good luck. And that was the first day on the job. So so had to order tooling, had to tool work holding, all that good stuff, put it all in there, and it was actually quite fun. And there's going to be an interesting segue here that has nothing to do with machining, but it was actually quite fun in the sense that everything that they were doing prior to that machine running, because they had never had anyone to run it before, was all being done manually. And so we were drilling holes in steel that were, 1.5 inches in diameter or 3/4 of an inch in diameter. And it was taking a long time to get through this steel. They just weren't doing it correctly. So let's say that by optimizing a CNC machine, it would reduce about 75% of that cycle time. Makes sense? So with that reduction in cycle time, I was actually performing hip-hop music at that time, and all of that different time cycle time, I was just writing music. I must have written about 150 songs in 2 years working at that place while just letting the machine run.
Oh, my goodness.
Completely different segue from machining, but I think as a part of that segue, and we'll get into kind of what I'm doing now with Air Turbine and these high-speed machining events where we're going around the country, this road show, and we've been, so many companies have been so gracious to host this event, and I think many people are finding it beneficial, and it's starting to have a snowball effect. But during these events, obviously, I have to make sure that I'm articulate and confident and standing in front of crowds and that I know what I'm talking about, right? And I think that actually stemmed from performing music on a stage in front of hundreds or thousands of people that had no idea what my songs were about, who the heck I was, and I had to just be as confident as I could, shaking so badly, and just do the best I could. Standing on stage in front of that many people creates in a more confident environment where you actually are embraced by people, a little bit more generous atmosphere, let's say.
Wow. Yeah, that's insane. That is really cool.
It was, yeah. We'll go into details on a different podcast when we're not talking about machining. I'll tell you all the stories about that. About the first time I ever performed, I was so scared that I dropped my phone, broke that. I refused to go on stage. My buddy was like, you have to. and I wasn't performing in front of my friends at a house party, and I was still scared to do it.
Oh my goodness.
That transitioned over time. So from there, I went into the woodworking industry and was helped run a shop floor that was 4 acres long for custom cabinetry. And we had routers and sanding lines and all that kind of good, brand new state-of-the-art equipment. It was where I first learned to program in Onsrud. And that was fun. And that was a lot of fun because everything was custom built and everyone could be creative. And then somehow along that journey, I got removed from helping on the shop floor to being in charge of the department that transitioned the interior designer's design, which could be pretty much as creative as a customer or homeowner could be. And then it had to make sense to the software, make sense to the machines to be able to machine it out. So there was that transition of doing programming through a software called Cabinet Vision. And Cabinet Vision brought everything together, let's say. So the interior designers designed one, and we put it on the shop floor, and we made it. And then along that transition, I moved somehow into the interior design and CAD department. I started creating kitchens and bathrooms. And I had no degree or information other than just being clever and listening. Then somehow I was working to the right-hand man of the owner, and our job was to bring a customer in, and he would sit down with the numbers and dimensions of his house and his kitchen, and the owner would ask questions to the customer, and the customer would tell them exactly what they wanted, and I had to design it in the moment during that second so he could visually see it be built and transition it during the exact time he said, nope, that's no good, I want to do something else.
Wow. That's some quick turn work right there.
Quick turn work, creative work. You have to make sure balance the customer's personality with practicality of how to create something in a kitchen, which I learned a lot about, or a living room or a bathroom, whatever it might be. And then they moved me from Richmond, Virginia up to Washington, D.C. And again, with no experience other than hands-on experience, somehow being in charge of the interior designers for the East Coast region up there. And, you know, I had kind of slipped away a bit from where I was and what I really enjoyed and to where I happen to be now and the stress that came with dealing with people. And I kind of looked at myself and my wife and I looked at each other, and she could tell I was real stressed out and said, well, what do you want to do? I said, well, I don't want to be here anymore. And we looked at each other and said, well, what do we like? Well, we like summer. We like the beach. Cool. All right, let's move south. So we picked up all of our stuff, threw it in a U-Haul, and drove south to Florida to more or less South Beach and just started living on vacation. And there was no real plans of who to work for and where to live and what to do. We just knew where we wanted to be, and we didn't want to be unhappy. We knew happiness was one of the most important things, or if not the most important thing, you know, right alongside family and family being part of that happiness. And the day I arrived, I was, you know, clever enough to send out my resume, and I had 3 job interviews, and the third interview I took was Air Turbine. And so that's been almost 9 years now, and I've been there ever since. And I am beyond grateful for the opportunity they presented me from coming in and being a part of their R&D and figuring out what does and doesn't work on the internal aspects of how to move forward, what's the best way to market moving forward, what can we fix and make better. And then somehow I ended up on the sales side of things again, and over the last 6 years, they've probably sent me to over 50 countries, 20 or 30, maybe more, trade shows around the world. I have the great honor and humbling pleasure to work with some of the smartest engineers in the world at places like SpaceX and Tesla and Facebook and Google and Samsung and Apple and all of these places. And, you know, I tell this joke all the time to my friends. I said, look, guys, I don't know how I got here, but for sure I walk into some rooms and I'm easily the dumbest person in that room. And then I walk into another room and I'm easily the smartest person in that room just based on what I've learned through traveling. And in both sides, I don't want to be a jerk. I don't want to be the idiot in the room that's not trying to absorb the information from really, truly intelligent people. And I don't want to be the jerk that already knows it all and thinks that he knows it all in his situations. So it's always important to absorb and to realize that everyone's our teacher, to respect one another, to offer kindness and generosity. And I think these type of characteristics are what allow us to create this symbiotic relationship in the manufacturing world, because as a part of this road show that we're doing, this high-speed machining event, we're working very closely with some of the OEMs, the Haas factory outlets and the Methods guys and the Selway guys. And each piece of this road show, we go around with as 4 companies, Air Turbine, Harvey Tool, Autodesk, and Fifth Axis. And all of us do our very best to offer on an educational platform without doing too much sales, how to effectively micro machine and high speed machine by combining all of the technologies together instead of pretending like we can do it on our own, because we can only offer a customer the highest solution when we do it together. You know what I mean?
Yeah, definitely. I think that's a great holistic approach to manufacturing that it seems like it's getting more popular, but definitely not the norm for the past, 50 years.
Yeah, I agree. So I've been talking for 17 minutes now and spilled my guts, which is probably too much, which is I probably bored everyone. So based on those stories, or is there anything that you guys would like to ask me?
Yeah, I mean, I
Yeah.
think we've got a bunch of questions both about, specifically about, air turbine tools and what you sell. I think that there's a lot of unknowns that people don't really dive into until it's too late. They always say that the machine tool the machine tool you buy when you need it is already too late, and so I feel like it's very similar with tooling.
Yeah, that's very fair perspective. So you want me to talk a little bit about what we've created and what we do?
Yeah, so I guess let's start, 30,000 foot. Like, I know it's the company's called Air Turbine Tools. So you guys make more than just CNC speeders. What does Air Turbine Tools make as kind of a whole company?
Well, Air Turbine has been in business for a little over 30 years, and they started with 3 hand tools over 30 years ago. And it's all they've ever done is high speed. So anything that's 25,000 to 90,000 RPM is the realm that they live in, or that we live in. And anything that's a 1/4 inch and smaller, 6 millimeters and smaller, that's the world they live in. So everybody else's outside the box is Air Turbine's inside the box when it comes to micro machining. Um, it's a unique technology that allows for a governed speed, which nobody else has. It's one of those things that's so simple on the inside. So to combine with that power, it allows for zero maintenance. It allows for no oil, no brushes, no gears, which also creates zero thermal expansion and no duty cycle. By keeping it so simple, it allows for the automation and robotics industry to have a thermal expansion, duty-free opportunity to just, if you think about automation, it's going to constantly run a lot of times 24 hours a day. And most components, when they're running that long, want to heat up, break down, burn out, need repairs, that kind of thing. So we create a simple solution that provides a service to that industry. Hand tools, I think, are self-explanatory. And then I think one of the greatest benefits in the CNC world is that if you buy a CNC, and let's say that CNC runs at 10,000, maybe 15,000 RPM, and I would say that the majority of us out there have 90% of our tooling and 90% of our programming is going to be above a 1/4 inch. Most of us, not everyone. The medical world gets fun sometimes. You get those small drill holes. You got, like you, Payton, you're doing that small diameter 15 thou molding for those weapons for the Lego industry. But most of us have, the majority of our tools are bigger than a 1/4 inch. The problem is that anytime you drop below that 10,000 or 15,000 RPM spindle just isn't enough. And what happens is we redline our CNC machines trying to create the surface footage that we need in order to push that tool and create the velocity that's required to cut through material at those smaller diameters. and it either breaks the machine spindle, or the machine spindle wears down quicker than it should, or thermally expands, and we just have longer cycle times than we're supposed to have, based on probably what we've quoted or what we want to quote to sell the product we're trying to make. And we have to justify that based on the fact that it's a 3-hour cycle time when it should be a 10-minute cycle time. And so what these air spindles do is the main CNC spindle stays locked into place of the say the Haas machine or the robo drill or whatever it might be, and you let the air spindle do all the work, and it's only the bottom piece that moves. So you M19 the program for orient and lock spindle on your CNC, and then you go 50,000, 60,000, 90,000 RPM on the air spindle, and you can finally get that velocity and that surface foot calculation and that RPM that you need to push that tooling at the rate it's supposed to be pushed. And Payton, if I'm not mistaken, when we were running yours on your DM2, we were at around 3 hours for that 15th thou ball mill. And although your finish wasn't perfect right away, we took it from 3 inches a minute to 100 inches a minute, which reduced cycle time from 3 hours down to 9 minutes. And then we started, doing focusing on the finish of the aluminum itself, and we ended up being, I believe, if I'm not mistaken, Payton, and correct me if I'm wrong, around 20 or 25 minutes and about 20 inches a minute versus the 3 hours that you were at 3 inches a minute by going from 10,000 RPM to 50,000 RPM, right?
Yeah, we were able to push the tool without breaking it, which surprised me, and like you said, dropped the cycle time for sure.
That's pretty amazing.
So that's kind of the concept. It's, people a lot of times, I guess it is hard to believe. I mean, when I first got to Air Turbine, I broke everything, and I tell people that all the time. I came from, big diameters like most of the people, and when I got in there, I didn't realize how important rigidity and runout was, and I would instantly create chatter and break tools with something that was 10 thousandths in diameter, and I had to change my way of thinking altogether. And so, like Payton just said, when I can't believe it could do that. I hear that statement so often. I didn't realize how insignificant RPM was. I have a voicemail that I show when I'm doing these high-speed machining events, and it's a voicemail from a customer who went from 8 hours to 8 minutes by drilling 94 holes. And people go, "Are you serious?" Like, it doesn't make sense for someone to not have that justification to buy one of those things, even if it's just for one job, it takes care of it. And on top of that, here's the other argument, Dylan. Payton and you and I have talked a little bit, but Dylan, I would love to meet you in person, and I hope we do after this, but some of this might be new to you. A lot of machine centers out there, which are fantastic machines, some from Germany, some from Japan, some other places, have the capability that you can purchase that machine spindle at 40,000, 50,000. I believe some are even main machine spindles up to 80,000 RPM or so, maybe even 100,000. But in doing so, by purchasing, say, $250,000 to $1 million CNC machine and purchasing that RPM, that specific high RPM, you've now given up all possibility for torque and horsepower on that lower RPM side. So you've now dedicated a machine solely to micro machining, where by applying one of these spindles, you have the best of both worlds. You have the ability to do all of your roughing and then rotate in the high speed when you need it.
Totally. Yeah, that makes sense. So does Air Turbine make tools that can go through the tool changer, or are they all manual load? Like, can you run through spindle air to drive these, or?
Yes to all of it. So based on CFM requirements, sometimes you can create a bottleneck in some of the smaller pull studs. So it would be really difficult to power our largest tool through something like a BT30, because the internal diameter of that pull stud is just going to be so small that you're suffocating the air. But as a general rule of capability, yes, you can use through spindle air to power these things. Yes, you can connect with external air and manually connect and disconnect like they used to do. Or we are one of the few companies, if not the only company, that creates patented what we call TMAs, which allow all these units to go through the ATC, through the tool changer, like all the other tools, by simply adapting a collar and a block to our air spindle and to the CNC machine. So this adaptation allows for full automation anytime you want to run the small diameter tooling.
Oh, so similar to like a 90-degree head stop block or something like that?
Similar to how you would see that working, yes. And just imagine it just going through the ATC and that nozzle or that plunger, as you might say, the male end of that nipple engaging into a female end of the block, and the air automatically kicks on. And there's tons of videos online of us doing that. So if anyone needs to take a look, they're everywhere. But yeah, it's you set it up one time and you're good for the life of the tool.
Okay, that's awesome. Yeah, I didn't realize that you guys had that. That makes the whole idea of manually plugging in air seemed like kind of a inefficiency, especially when you're talking about automation and things like that. So that's great.
You're exactly right. When you think about 80% of our purpose is to reduce cycle times and speed up everything that we're doing. The fact that you have to either pop an MO1 in there or whatever it might be to stop the machine and then load it and unload it, connect and disconnect, now you're losing time again. So by implementing this automated procedure, it takes away that slowdown of what we're trying to avoid anyway.
Totally. So you kind of touched on this, but in the speeder market, there's air turbine, there's coolant driven, there's electric ones. What specifically makes turbine spindles, the best choice when it comes to high speed spindles? What is your guys' claim to fame? You said, zero thermal expansion. Like what makes your guys better than those other options?
With respect to everyone in the industry, and it's kind of a niche industry as having an accessory in high speed, but with respect to everyone, there is a use for everyone's product depending on what you have to do. And I think it's up to us to provide the best education for a customer to make that decision on their own instead of just giving a sales pitch and always believing that you're the best for every operation, because it doesn't work like that. But with that being said, what sets us apart in that world, I believe, in summary, is simplicity. So you don't have to worry about gears breaking down or brushes burning up or applying oil or having an external gearbox that's going to cost extra money that has to be maintained. You don't have to worry about your coolant and your filter through the coolant always being clean and having to back up the main machine spindle. You don't have to worry about that duty cycle over time of that thermal expansion, and then the manual loading and unloading of the tools themselves. And on top of that, we would argue that within the range of our RPM, and I've seen it happen in lots of head-to-head tests, but I'm always open to more tests and more learning. We would argue that by comparison in the high-speed machining world, that we're able to generate the most power. And I'll tell you a quick story about what that actually means, because in the big scheme of things, torque and horsepower aren't huge contributors to something that's 10 thousandths in diameter, right? Because it's just tiny and all you need is RPM. So I'll tell you a story. I'll tell you two stories. So we were seeing what these spindles could handle one time, and we were hanging out with our friends at Doosan over in New Jersey, and Kennametal had come in with their new 6-flute 6mm ceramic tool, and we wanted to see what 40,000 RPM air spindle could do on a piece of Inconel. And so we were going 160 thousandths deep at 200 inches a minute and 40,000 RPM, and we were just plowing through this Inconel. And if you watch the video of this Inconel, it's not really, in the machinist world, a practical way to make a 10mm wide slot. But what we wanted to show and justify was the capability of the power that could be generated by utilizing the air spindles. So we took that knowledge and then applied it into a practical world. And in the practical world, I was working with my friends over in Korea. And we went head to head with some really great companies with similar products. And we all had to give an apples to apples trial to the exact same thing. So we were machining a piece of mold, and this mold was just a sample piece, but it was supposed to resemble the mold for the back of a TV, right? So we all had 50,000 RPM. We all had 1mm or 40 thousandths in tool diameter. We all had the same depth of cut. We all had the same material. So there's not a lot of variables that you can play with when it comes to so many of the same apples and apples. However, the one thing you can play with is your feed rate. And the only way to go faster if you're at the same depth of cut and the same material and the same RPM at the same tool diameter is by upping the feed rate and by having more power and the capability to do that. So in direct competition, and I haven't translated this in my brain, so I apologize. I'm going to talk millimeters because I was there and I know what was programmed. The competitors were at 8,000 millimeters a minute. And we maxed out the machine at 12,500 millimeters a minute. And we wanted to go faster, but we couldn't because that was the max of the machine. So that difference between 8,000 and 12,500 was a difference in a sample test piece of 6.5 hours and 4 hours of cycle time. So if you apply that, that has directly to do with what power capability gives you at 40 thousandths in diameter. Does that make sense?
Totally. Yeah, that's significant.
And so that's what sets us apart in that world, between the simplicity and the full automation. That unique turbine, which nobody else has, is what sets us apart, that power difference.
Yeah, I mean, that's 315 inches per minute to 492.
Thank you for doing that math for me. I do appreciate that.
Yeah, I know that at least the statistics show that a lot of our listeners are in the U.S., so...
Yeah, because I travel to so many places, and I remember things exactly as they are, and I don't always translate them. I apologize for my constant transition of inches and millimeter.
No, it'd be probably best if we all boned up on millimeters a little more anyway.
You know what's funny is I saw a post go up in Titans of CNC about millimeters and inches, and I don't know if I've seen more comments underneath that than any other post. It's always interesting to see the perspective of everyone. No, inches are better. No, millimeters better. Neither one makes sense. What are we doing?
Yeah, they're all just numbers.
So, Tony, you want to tell us a couple cool stories? I know when we were talking, when you came to my shop, you told me about some crazy cycle time reductions, some crazy, companies that you went to, maybe some that you shouldn't have told me, but just cool stories and, just kind of, I don't know, just tell us some cool stories.
All right, so some details I can't say. You're exactly right, because there's a lot of NDAs that have been signed, and sometimes I can't say names, but I do have a few companies that I can talk about very legally. One of my favorites is this company called Torque Motors based in India, in Pune, India. And they make electric motorcycles. And they've actually won the world competition on the Isle of Man over in the UK with their electric motorcycle. And I believe the newest model is going to be released shortly, if not already in India, but shortly in other places. And I had the opportunity to ride this motorcycle around and drive it and then see how quick and how fast it could be. And the fact that you're able to add 4 batteries to it, and each battery can go, I believe it's like 100 miles or 200 miles or something like that. So we went in there and we did some tests, and those people were absolutely amazing. And every single one of our tests reduced their cycle time by about 90%. And that had to do from aluminum slotting to contouring of electrodes to engraving of small parts. Everything that we ran was reduced by such dramatic cycle times that they were able to take the idea and the concept of applying the air spindles to their product and then have the discussion with the government of India to negotiate larger projects of growing the electric world of vehicles based on the fact that they're able to reduce their cycle time. And not directly related to Torque Motors, but to my knowledge, and I might not be specifically correct, but to my knowledge, the Indian government recently invested about 50% of their automotive budget into electric motors over there. So there's a transition between the Tata Motors, which have been the most famous, into these new electric ones that are trying to create a cleaner environment, which I think is very beneficial in a country with 1.5 billion people.
Totally. Yeah, that's amazing.
Yeah, I think so too. I think it's worth a try, right?
Definitely.
Let's see, what other cool stories? There's been so many, and I get to work with such brilliant minds. What one have I told you, Peyton? Do you remember?
I can't remember. There's too many, to be honest.
I can tell you places I've walked into many times, and I can't bring a story from it. I do like sharing the Inconel one from earlier, the one working with over in Korea, a couple of the ones in India. We do work with a company called Titan Watches over in India as well, and Titan Watches creates, I think, 30 different models of watches and maybe over $100 million in watch sales. I don't know. I'm making things up at this point. Don't quote me. Don't quote me. But we were able to hop on one of their machines again and just apply 50,000 RPM to a situation. And it was only a 2.5 minute cycle time that we were able to reduce by 50%. And we try to justify, well, if you've only given me 2.5 minutes, how much can I really reduce it, and how many times do we have to do that in order to justify $5,000? But we were able to do it, and I guess when you're making 100 million watches or whatever it might be, then justification comes through time.
So that's actually a good point that you brought up. What's a rough cost of one of these air speeder spindles?
About $6,000.
Okay.
Yeah, it's a rough
That's
estimate. Some are less expensive, some are a tiny bit more, but even on your most expensive day for everything on our heaviest, largest model, you're still looking at about, and let's say through spindle coolant even, or a 90-degree tool, or one of our variable speed spindles that we offer now, you're still looking at around a max of about $8,000.
okay. That's not bad at all. So
And
what's the longest single runtime you've seen on one of your turbines? Like how long is the longest cycle you've seen?
I am very happy you brought that up, because that would have been a story I would have told. So we have some friends over in England that go by the name of Technicut, and amazing company, and they make all their own tooling, and they work primarily in the aerospace world. So pretty much any aerospace company you're thinking of, they probably provide tooling to them, and if they're not, they're working on it. They have a couple of amazing machines, including 2 or 3 Hermeleys, and I believe a Mitsui Siki just came in, and we wanted to test their tooling with our products. So, unbeknownst to us, they wanted to see if the words coming out of our mouth were just a sales pitch or technically sound. And so they took our air spindle and popped it on one of the Hermeleys and started cutting titanium. Um, and the longest cycle time that they tested our spindle out on was 12 hours. And in that 12 hours, what they were testing was thermal expansion. So during that 12 hours of cutting titanium on a Hermelay machine, after the 12 hours, they found 9 micron of thermal expansion. However,
Jeez.
when they looked at the tool itself under a microscope, they realized that 8 of those micron had to do with either tool wear or the titanium that was stuck to the end mill itself, and only 1 micron after 12 hours was due to thermal expansion.
Whoa.
My goodness.
So that's the longest
That's
cycle
insane.
time I've been a part of, yes. But with that
Wow.
being said, you made me think of another one. All right. So we're working with these guys in Korea. And this is ridiculous. We're working with these guys in Korea, right? And they're doing subsidiary work for one of the major companies who you guys, I'm sure, know, and you might even have their phones, but I won't say any more. And they have a uh, uh, 1/8 inch hole that they need to put 102 thousandths drill holes into. And they have to do this so many times on one sheet of metal. And this is in, and I don't have it memorized, but some really hard steel. I actually have it documented, but I don't have it in my brain right this second. So really hard steel, 2 thousandths diameter drill holes, and you're talking thousands of drill holes and 100 of these things within a 1/8 hole as well. And their cycle time, to my knowledge, was 32 days. 32 days. And we were able
This is the one I was talking about, Dylan.
Yeah.
So 32 days, and each drill hole, give or take a second, was around 32 seconds, coincidentally. And we were able to add a 50,000 RPM air spindle and change the feed rate just a little bit. Peck cycle more or less remained the same, but feed rate just a little bit. And we reduced the cycle time from 32 seconds per hole to our best finish time was 13 and a half seconds per hole. So if you reduce that incrementally based on the 32 days of cycle time overall, then imagine reducing a cycle time from 32 days down to about 13, 14, 15 days.
Wow. I can't imagine even just running something for half a month straight. That's insane. But
So
I mean,
right.
let alone for a full month. That's bananas.
And
That's really
don't scrap
insane.
that part. Don't you
Right.
go away and lose your job if you scrap that part after half a month of programming.
My goodness.
I thought you told me one, Tony, that was related to drilling holes for some. I can't remember what the material was. Some small diameter hole for like an electrical something or other, and it was like even longer cycle time. Maybe I'm making something up.
You're not making something up. It's actually a project we're still working on, and we've done a lot of testing. And maybe these people will be listening to the podcast because I'd love to get back in the doors. But in the Pacific Northwest, there's a lot of what's called shower heads, and these shower heads aren't actually what you're thinking of when you hop in the shower and these tiny holes and the water comes through it, but gas passes through it. And I'm not allowed to give the details of what actually is done, but it's 25 thousandths diameter and smaller. And some of these plates have a month's worth of cycle time. And we were able to reduce it by over 50% in all of the trials. It's one of those things where it's got to be implemented on such a huge scale that you have to justify cost for it. And our recent release of our through spindle coolant model is the reason I want to get back in these doors and do them again.
Oh, so you guys actually released a through spindle then?
We did, yeah. Air comes through the side, coolant through the back, and it really helps with all that small diameter drilling. To the extent
Oh, so
that
the coolant doesn't drive it at all.
Sorry? No, not like
Okay.
not like the coolant
I got
driven ones. We're still driven by that same powerful turbine. We just have a hollow shaft that we're sending coolant through the back end so you can have the best of both worlds.
Wow, that's really impressive.
Thank you. We've been working a couple years on that.
That is really cool.
So what else you got for me? Are you bored of me yet?
No, of course not. You were talking about a variable speed one. How does that work? I mean, is it controlled by changing air pressure or?
That question is asked a lot, my friend. It really is. So in the majority of people's brains, I think when you think variable speed, you think programmable or air pressure change. And programmable makes sense, but it often comes with some sort of electric box. And air pressure makes sense, except when you reduce air pressure, you reduce all of your power as well. And so now you've reduced your own capabilities immensely by changing the RPM lower. And typically most people, for torque and horsepower reasons, want to keep the PSI pretty high on that regulator. So what we've created, we could have actually nicknamed it dual speed instead of variable speed, but variable speed to me sounds better. And so what you do is there's two turbines on the inside of our spindle, and there's a nut or a washer on the inside. And so you take a wrench and you can screw that nut all the way forward. And what it does is it seals off one of the turbines, and so you're running at one speed and you're running one turbine. And so then you can back that nut out through that same wrench, and then you're running two turbines and running at a different speed. So that option goes from 25,000 and 40,000 on our power model, or 30,000 and 50,000 on our kind of our do-all model.
Okay. Yeah, it's like coils in a electric motor. I gotcha.
Similar, yeah. And you just take a
Similar, yeah.
hex key and push it forward or pull it back, and it gives you, change in RPM without sacrificing any of the power that we talked about earlier. But it's not going to
Okay,
be programmable, to answer the original question.
gotcha. So with all this high speed machining talk, are you starting to see these kind of enter more job shops, or are they still very specific? Because it seems like, especially like some of the things I'm seeing on your website, it seems like maybe you guys are l- aiming towards higher, uh, more shops to have these, or like making them more or easier for shops to get. Is that correct?
There's a long answer to that. Of course, it always is when I just start talking. And sometimes people are like, why did I ask that question? uh, the answer is kind of yes to all of it. Job shops want to see if by purchasing the tool and they have to do a job, can they justify it before moving on to the next job that may not require that higher RPM? So they want to see immediate justification. Whereas some of the larger shops we work with, like I work with one company, did a ton of testing there that have 70,000 of the same machine. And it's like a hall of mirrors. Oh, sorry, I mistaked my words. They have 50,000 of the same machine with 70,000 employees. And it's a hall of mirrors when you look through there. And so if you save them um, 30 seconds of one cycle time that's implemented at such a high rate of finished product that it can pay for itself fairly easily. Um, but as Payton would realize, because I've come to see him, we work with anyone from the smaller shops to the 50,000 CNC shops. We work with everyone, and I'll say a couple of names without details. We work with everyone in the big names of the Facebooks and the Googles and the SpaceXs, down to the guys who are gonna be massive one day, but at the moment working in their garage. Payton, let me tell you a story real quick. I'm not sure if I told you this. Dylan, you might like this
Okay.
too. So I was out in Cincinnati recently, and a guy from Cincinnati had recently gone to one of the trade shows and stopped by our booth. His name was Dan, and he's working out of his garage, kind of a little in the middle of nowhere, and I was very happy that my Uber driver didn't leave me, because I wouldn't have had an Uber driver to get back. For sure, nobody was there. And I didn't even see any cows to ride back into town. But so he was in the middle of nowhere working out of his garage. Super nice guy named Dan. And I start telling him your story, Payton, because I think, okay, similar environments. He's got a Herco machine. He's trying to do something similar, and 15 thou diameter, and he's doing these aerospace parts, and sometimes it's aluminum, sometimes it's steel. So I start telling him your story, and he goes, Payton Dean? I listened to his podcast.
No way.
Dead serious. Dead serious. So
No way.
Dan decides to reach out from Cincinnati, Ohio. You know where that guy came from.
Dan, I better see a message on Instagram.
That is so cool.
Yeah.
That
Yeah.
is
It's
really
a small
That's
world.
crazy.
When we all start working together, and all the guys that really want to, benefit one another, and we're pure to this industry, it becomes small, and you want to be. I think we all want to be true to who we are and true to business, because by doing it any other way, everyone's going to find out. And so it's great that you guys are doing this podcast, and as with the beginning of this conversation, with all the relationships and piggybacking off one another, and being a part of making everyone else better instead of crabs in a bucket. I'm grateful for what you're doing, and I consider Titan Gilroy a friend of mine, and I like what he's doing with the Titans of CNC. I love that Autodesk is offering free software for the education world. I'm just grateful for what I'm seeing in the future of manufacturing, based on how much of it was exported over the last couple of decades.
Totally. Yeah, and we really appreciate you coming on, because that's one of the reasons that we wanted to start having guests, is kind of both to show off, let people show off their own shops, but also have people like you who work for manufacturers of specialty tools or specialty products that, people might not feel comfortable, like, if they are in a small shop in their house, reaching out to you and feeling like, quote unquote, wasting your time. Whereas we feel apparently no guilt wasting your time and bring you on and ask all the questions that they want to hear. So
Remain guilt-free, brother. I appreciate it.
Yeah, I mean, other than that, Tony, is there anything you want to plug while you're on here?
I think I kind of did already. Every time I think of someone,
Okay.
I give them a shout out. If you notice, I mentioned a lot of our partners already. The Doosan's and the Haas's and the Hercos and the Methods and Robo Drills and a lot of the companies we work with. And I wanted to show you guys some love as well. And all the partner companies of Fifth Axis and Autodesk and Harvey Tool and these genuine companies that are out there doing everything that they can to make the industry successful and make companies profitable. So I think I've already done that, and I just repeated myself because you kind of made me.
Well, so if anybody wants to get in on these high-speed machining events, are there any spots left on upcoming ones?
Next week in just outside of Cincinnati, Ohio, is already at full capacity. Maybe you could stand outside the door. I'm just kidding. Don't do that. It's probably going to be full. But there's registration links. If you go to airturbinetools.com and you go to some of the events on the top bar of Air Turbine Tools, there's registration links for each of these events. In this month, we'll be headed to Arizona. We'll be headed to Ohio, then Arizona, then Southern California. And then on the list throughout this tour includes a couple of spots in Northern California, Washington, Oregon, Southern California again, probably heading over to Utah. We got Michigan. We got Chicago. I think Chicago twice. We're then going down to Little Rock and over to Tennessee. And I believe we're going to commit a couple other spots over in the Pennsylvania and Virginia area, just kind of sorting those details out. So it's really all over the nation. And if you're semi-local, by all means, come by, say hi, and be a part of it.
Awesome. Well, yeah, I'm looking at the Arizona one right now, and I might have to try to sign up and get up there that day.
Yeah, please do, man. You'd be more than welcome. It'd be awesome to meet you there. And the guys over at Methods, some of the most brilliant guys and friends I've had for the longest time in the industry. Tony Campos and Tony Harold are two of my best friends in the whole industry, and genuinely great people. Even before they were in the positions they were in, there was a Chris Porter and a Bruce Field, and they ran that place for years and years. So it's just, I wish all the success for them. I'm grateful they opened the doors for this event as well.
Very cool. Well, again, thank you so much for coming on the podcast. I know I've definitely learned a lot about Air Turbine Tools, and something to keep in my back pocket if I ever find myself needing one. I'm now I know who to turn to for sure.
Well, I'm happy I didn't put you to sleep first and foremost, and then that you actually learned something from me. I'm going to be able to sleep well tonight, I tell you.
Yeah, well, thanks again, Tony, for coming on. And once again, guys, we will be back next Tuesday with Dylan and I with the normal podcast, and we'll see you then.
Cheers, guys.